Hey everyone, and welcome to episode 2 of my Help with Maths homework series. So you guys send in your questions on my Facebook group, and then I pick the ones I like, and you vote for them. So you vote for which questions we do. And today we're going to cover projectile motion, which is most voted by you, and linear relationships. Okay. Normally I do 3, but because I'm worried the video time will be too long, we're going to split into 2 videos. So let's get into the first question. So before we start with question 1, tomorrow I'll upload the video with the other 2 questions. That way it'll be shorter videos, you'll be able to watch them on which ones you want. So today we're going to do linear relationship, projectile motion, tomorrow trigonometry and inverse trig, right? That way I thought those 2 would go well together. So the first question we'll see here, so for what value of k will the lines negative 3x plus y minus 5 equals 0 and kx plus 2y plus 3 equals 0 be either parallel or perpendicular? So parallel lines. So all you need to know about parallel lines is there are 2 lines that never meet, which means the only way that can happen is if they have the same gradient. So that means m1 equals m2. Now you'll realize this is not in gradient intercept form. So if we make y the subject, we get y equals 3x plus 5. And over here, we get 2y equals negative kx minus 3. Y equals negative k on 2x minus 3 on 2. So that's my m1, that's my m2. So if we sub that in, negative k on 2 equals 3. So now that's just a simple equation to solve for k. So to get rid of the 2 on the bottom, it's dividing, we times it over. So negative k equals 3 times 2, which is 6. And last, to get rid of the minus by just swapping it over. That's all you have to do, or divide by minus 1. So k equals negative 6. Right, that was simple enough. Let's go to B. So now perpendicular lines. Well, perpendicular lines have the product of their gradients equals negative 1. So if we plug it in, it's negative k on 2 times 3 equals negative 1. So we need to solve for k. Again, we can times the 2 over. So this is negative 3k equals negative 2. And then to make k by itself, we just divide the negative 3 over. Negative 2 on negative 3, and k equals 2 on 3. Right, so it's a pretty straightforward question, but you've got to make sure you know those differences between parallel and perpendicular lines. Okay, hopefully whoever posted this question, this helps. And let's get to the projectile motion question. Okay, projectile motion. So a particle P is projected from the point A, which has position vector 47.5 j. Now, if you know what that means, point A, so j refers to the y-axis. So 47.5 j means of height 47.5. So we're on a cliff, and it's going to project from that height with respect to a fixed origin O. So the origin is there. The velocity of the projection of P is 2u I plus 5u j. So what that means is if we draw projectile, it has an initial velocity v. Okay, so v it's being projected in that direction, but the x component is 2u, and the y component is 5u, right? Because it's broken it up for you. It's told you velocity is 2ui, so that's the x component, and 5uj, 5u is the y component. So that's really going to help us with the first half. The particle moves freely under gravity. So we've got gravity, which will say is negative 9.8, and it passes through the point B with position vector 30i. So this is the point B. Now 30i means that's the point 30. And then the question is, show that the time it takes from P to move from A to B is 5 seconds. So essentially the question is saying, show it takes 5 seconds for this particle to reach the ground. So in order to do these questions, we need to derive our equations of motion. So we always start with y double dot and x double dot. Right, so those are x and y accelerations. Right, so projectile motion, we look at x and y individually. And here, y double dot is just going to be negative 9.8 and x is 0 because they've currently, all they've told us is it falls under gravity. So that means there's only y acceleration. Now to get the velocities, right, so y dot, we need to integrate with respect to t, right, because these dots mean differentiate with respect to time. So if we integrate here, we get negative 9.8 t plus, now we don't need to worry about what plus c is because this diagram tells me my initial y velocity, so this is my initial y velocity if you want to think about it. I won't use this I to confuse us. So that's just plus 5u, right, because when t equals 0, y dot equals 5u. And the same with x dot, that's just going to be 2u, right, because when t is 0, x dot is 2u. So they're my equations for y dot and x dot. And lastly, I'm just going to need my y and x equations. So we integrate again. So add 1 to the power, divide by the new power. Right, so that means we'll be dividing by 2. So 9.8 divided by 2 is 4.9 plus 5ut plus 47.5. Because we start when t equals 0, the starting point is 47.5. And then x will just be 2ut because the starting point is still x equals 0. So there are my equations of motion. And we need to find t when. So we want to find t. If you look here, the point x equals 30 and y equals 0, right? Because that's the x-axis. So we've got two equations with two facts to sub in, and we want to find t. So let's sub that in. So if we sub in here, we get 30 equals 2u on t. So if we want, we can say u equals, it'll be 15 on t. Okay, so there's a reason I'm subbing u and not t, because we want to find t. So the key is to get rid of u. And then if we sub 0 into here, we get 0 equals negative 4.9 t squared plus 5ut plus 47.5. So now to find t, we've got two simultaneous equations. U equals 15 over t. And this one, so all I've got to do is substitute that for u right there. So we get negative 4.9 t squared plus, now look what happens here. This will turn into 75 because the 1 on t will cancel with this t, and it's 5 times 15, which is 75. So look at this is a very simple equation to solve for t now. So if I bring this term over here, 4.9 t squared, that's 122.5. T will be the square root of 122.5 over 4.9. Just get your handy pocket calculator. And 122.5, 4.9, what do you know? 5 seconds. All right. So the key with these projectile motion questions is to get your diagram right and set up your equations. Once you have all of these equations, you just got to write down what you need to find and what you're given. I need to find t. I know x is 30, y equals 0, and I've got my equations to sub in. All right, then it just becomes your algebra skills with simultaneous equations. That's pretty much how projectile motion works. Okay, so I hope whoever had this problem, this helps, and tune in tomorrow for the next homework series questions on trig and inverse trig. So make sure to sub and turn on post notifications so you are notified when this video is released.